Hi, good afternoon, everybody. If you can hear me, just confirm in the chat quickly. I also need you guys to take note of the schedule of the topics we will be going through this upcoming week and next week. So please take note of the days, especially if you know a specific area is your weakness. You would know what days to prioritize, even though I expect you guys to try to attend all. So today we're going to go over question 9 because we have completed everything we need to know to answer whole question 9. So that's what we're going to focus on today. Tomorrow we are going to revisit vectors and matrices. So let me just pull this to the side so that you guys can see. I need you guys to take note of the schedule so that you have this information on hand. So today, question number 9. And question number 9 is geometry and trigonometry. On Monday, we will be focusing on vectors as question number 9, number 10, sorry. Tuesday, measurement. We have not gone through this question yet. That will be question number 6. So it's very important that you guys, if you cannot make it to the live class, you ensure that you watch this video. As I mentioned while we were going through it, the questions are all based on real life objects. So the content isn't difficult, but understanding how to read the objects is what creates the challenge. Then Wednesday is question number 3. We have not done question 3 either. This is geometry, the basic geometry. And trigonometry as well. This usually involves transformations, which we will do using questions because it's 4 different types of transformations. And with practice of questions, we're going to learn and get used to those types of questions. And then Thursday will be question number 8. Again, this is advanced algebra. We have not touched this one yet, but we've covered everything we need to know for this question. All right, so let me know when you guys finish copying by saying done. For those who joined, this is our schedule for this upcoming week. Just for a heads up, the week after, Monday's a holiday, so obviously there won't be any class on that day. But the Tuesday, we're going back from question 1. So Tuesday's question 1, Wednesday's question 2, Thursday's question 3. So you see, we are really going back over everything from top to bottom for every question in the paper 2. Now, the week just before exams, we're going back to paper 1. In the meantime, I really do expect you guys to put in the paper 1 practice on your own. And you should be timing yourself. Never do a paper and not time yourself, because you need to be honest in where you are in finishing the paper. So you know, okay, am I struggling? Am I not struggling? So we could organize what you need to do to finish. All right. So before we jump into it, I just need everybody to just confirm that they're good to go with everything they heard in terms of our schedule. Please, I want to take this opportunity to let you know, in a huge way, you are responsible for yourself. Okay? Whatever we do in class will not be enough. I sent you guys several sources of things you could use. Use the website fastpass.com. What I love about it is that it has notes, it has explanation. So let's say there's something that we didn't get to cover. There's everything that you could actually learn directly from the past paper solutions. Okay. So let's jump straight into question number 9. As you know, question number 9 is a geometry and trigonometry that has to deal with angles, circle theorem, Pythagoras, cosine rules, sine rules. So the first part is always circle theorem, generally. All right. Now, my first question to everybody, and be honest, how much people remember the circle theorems? Be honest, be honest, be honest. If you was to rate yourself on what you remember on the circle theorems out of 10, quickly, how much do you remember about the circle theorems out of 10? Because if we don't know them, we can't learn them, okay? I'm trying to see if I could find the quick summary notes. I found it. So I'm just going to quickly go over it. Again, this is something you cannot have. I'm looking for another word for half-ass, but I'll just say it. You cannot half-ass circle theorems. You have to know the theorems out of your head. So if you know you don't know them, please make sure you take some time to remember. So let's go through them quickly so we know how to refer to our circle theorems. All right, so the first one, pretty simple. Angles at the center is 2 times angles at the circumference. What are the things we're looking for? We're looking for angles that are formed on the same line, or in this case, we know the name of this line. This line is called a chord. All right, so in the center, this angle is formed. It is always 2 times the angle here at the circumference. Keep in mind, this could have gone to the side here. It's the same thing. Or the angle could have been made on the side over here. Once they have the same beginning point and end point, that rule applies. Second one, I call this the twin angles. So here we realize all 3 of these angles were formed on the same chord and they all touch the circumference. All of them would be equal. Angles on the same chord are equal. Next one, we have the diameter. We must remember that any line or any chord that passes directly through the center of a circle is the diameter. And so what do we see here? There's an angle being formed on the diameter. That angle is always 90 degrees. So we say angles in a semicircle, no problem. It's either angles in a semicircle or angles on the diameter. That's the things we're supposed to be looking for. So let me just go back quickly over these 3. In your mind, these are the rules you should be looking for. Next one, cyclic quadrilateral. Why do we call it cyclic? Because the vertices, and we should know what vertices mean. Vertices is the plural for vertex, which is another word for points. So the 4 points of the quadrilateral must be touching the circumference. Now, here we see that we have 4 angles and we know all of them add up to 360. So that's the first thing. But the most important thing says opposite angles, which means the angles that face each other are supplementary. We got to remember what supplementary means. It means that the angles add up to 180. So A and B add up to 180, C and D add up to 180. This theorem don't really come often, but it's pretty easy. Anytime you have a chord and this is like a partial form of a radius. Anytime there's a line that connects the center to the chord, it's always 90 degrees, which is pretty similar to the one that we know. What are the 2 elements here we need to see? The T, which represents this line, the tangent, which is the line that touches right on the circumference of the circle. Whenever the tangent intersects with the radius, an angle is formed, and that angle is always 90 degrees. And what you should know, if this side is 90, over here is 90 as well. Okay. Next one, this one deals with 2 tangents. So whenever 2 tangents meet at a point, the distance of those 2 tangents or the lengths of those 2 tangents are equal. And I connected it to show you that it creates a triangle. Anybody remember the name of this triangle? What's the name of this triangle that has two equal sides? Isosceles. Excellent. And so the last one, and please remember, this is the one we always forget. The internal or the external, sorry, is equal to the internal opposite. And you see, have it on both sides. Look at what creates the external angle. What is this line that makes the external angle? A tangent. So whenever you see a tangent and a triangle and you realize this is a cyclic triangle, it creates the external angle. So these are the things your eyes have to see. You should know what this means. Two lines intersecting, A and B are vertically opposite. That means they're equal. Here we see an example of an external and an internal. And what we should see is that both of them are on a straight line, which means they add up to 180. So we're doing a quick revision because these are things we should know. Similarly, we have two parallel lines and we have a line cutting those parallel lines, which is what we would call a transversal. It got a lot of angles here. And you should know all of the angles associated with this image. You should know the Z, which is the alternate angles. So the Z, this angle and this angle are equal. You should know the internal angles or co-interior angles, which is these two, and they are supplementary. They add up to 180. Also, you should know the corresponding. What does the corresponding one mean? If it holds the same position, they are equal. So let me just quickly draw that last thing and then we're moving right along. So I hope everybody remember everything I'm talking about. Be honest. Because at this point, you should remember everything. You should know everything I'm talking about. So here we know we got 4 angles to the top here. And we got 4 angles to the bottom here. We have a top left, A. And a bottom here, we have a top left again, B. We know A and B is equal. Same thing, let's use a different color. If I call it C, I will call up here D. We know C and D are equal because both of them are the top right. Then we have bottom left. Let's call this E, bottom left. I'm gonna just use the same letter E. Bottom right, F, bottom right, F. That's what we call corresponding. Because they hold the same position, they are equal. These are the things we need to know. Any type of angle that you don't know, even if me show it here. So you know, if I had a right angle, right angle, which is a 90 degree, and I split it up in 2, I know these 2 must add up to what? They must add up to 90 degrees. And we call a complementary. We know angles in a triangle add up to what? Quickly, who could tell me fast? All 3 add up to what? 180. These are the things we must remember. Okay? All right, so let's go right back into our paper. Right into our session today. So my January 2022 just disappeared just like that. Hold on, y'all. See the devil already trying to test us. How the thing just disappeared just so. That's crazy. Okay, it's back. All right, so if you're ready, tonight we have to finish all these questions. So I hope everybody is mentally ready to look on, to follow, take notes, revise, because we have 3 weeks to go, 3 to 4 weeks to go. That's not everybody saying ready. Let's go. I don't ask for much. I ask for correspondence. I ask for people to respond. Let's go. Okay, so what is our strategy with question number 9? Do you go and look for the questions? You do not. You look at the picture and you try to see all of the rules that you could see. So I am going to do it quickly and I'm going to hope that you guys will be able to follow as well. So first thing first, when I look at this image, I see 2 triangles inside. And the 2 triangles that I see one that is formed on the diameter. I hope everybody following. So just make sure you're following. I know immediately that there's a rule that says that this angle here must be at 90 degrees. Me ain't even looking at the question yet. I just know based on the circle theorem, this is 90 degrees. Next, when I look at the image, I also see another triangle here, and it's a cyclic triangle. What I realize about them two triangles actually, that both of them connect with what? The tangent. So you know what rule we should be looking at? The external angle. Look at the external angle. And so I know this angle here would also equal to this angle here. I hope everybody's seeing. And there's another one that they ain't talking about, this one here. Okay. There's a next theorem as well. Whenever you got tangent, you should look to see if there's a radius. Is there a radius? Yes, because if this is the center, this line is a radius. What does that mean? It means that this angle on this side is 90 degrees. So when I step back now, I kind of am ready to look to see how I can find my angles. Everybody see what I just showed you? Okay, so let's jump straight into the question now. Question number 1. So again, strategy, do not go look at the question first. Look at the picture. Make sure you could see as much of the laws as possible. Because when you look at the question, your brain done ready. Your brain done prep to tell you, okay, I remember I saw this, so do this first. Okay? Oh, excellent. Excellent observation, Austin. Thank you. He's very correct. Look at the twin angles here. This and this is twin angles. And you know, I was going to start off with that one and I forget to, so thank you. Excellent, excellent. Everybody see that? How do we know that they're twin angles? They are both on the same line. And honestly, that's what I'm expecting from this session. If I tell you now, I know I'm extremely exhausted. So if please look out for any mistakes, because that's the type of vigilance I need from you guys. You don't expect me because I say something, you just leave it there. Make sure you verify it as well. Ask a question. That's what we're here for. Okay. So excellent observation. So we see here we have a whole nother theorem, which is twin angles. We know Y and Z are equal from the jump. Okay. So let's go into the question. Probably need to get some more coffee, but I'm ready to. So the first one it asks, make sure you read it. Always read. Determine the value of each of the following angles. Show detailed working where possible and give a reason. We already know what they mean by give a reason. State the rule that you use. State the theorem that you use. So let's look at X. Here we see X here. But what do you know as a mathematician? It may not be easy to identify X just so, because if I look in this triangle, this really doesn't give me anything to work with. But look on the opposite side. What information do you know that could help you put something together to find X? You know this is 2X and you know this is 3X. What else do you know? Don't you know the value of those two angles? We already know two of them together create what? 90 degrees. Tell me if you've seen it. Two of them together create 90 degrees because it's the angle between the tangent and the radius. And because we don't identify it, we could do that easy. So here's how your working should look. 2X plus 3X is equal to 90 degrees. And what your reason is going to be? Angle between, what's the angle between? What are the two things the angle is between? The radius, very good, and what? Excellent. And tangent, you have to say it, is 90 degrees. You must say it. Then, based on what we know, we can solve for X. Don't we know how to solve for X? So we continue. We know 2X plus 3X is what? 5X. 5X is equal to 90. We continue to transpose. How do I transpose? I divide by 5 on both sides. Everybody got their calculators up because I can't find mine. So I'm going to need y'all to calculate for me. So 90 divided by 5 is what? 18? Not sure. Somebody? 18 is correct? Excellent. So 18 degrees, just like that. So we continue. So we get with 2 marks. 1 mark for your calculation here, 1 mark for stating where you get the information for your calculation. Okay. Next question. And what I do, I like to take my pencil and plug it into the picture. So I'm gonna just chuck in here 18 degrees. Always put the information in your picture. It helps you to assess the rest of the stuff. Okay. All right. So let's go. It says Y. So when I look at this image, what information allows me to find Y? Look at where 18 is. Look at where Y is. Don't we have 2 out of the 3 angles in this triangle? Because if we look at it, did we know here is 18? And don't we know this angle here? What is that angle there? Based on what we spoke about earlier. 90 degrees. Remember the rule? This the triangle here. Then the triangle formed on the diameter. So the angle that touches the circumference is 90 degrees. How do we find the missing angle in a triangle? What do we say? We could say 180 is equal to, what was the other angle again? 18 and 90. Not 180. Sorry. Let me do it again. You would say 90 degrees plus 118 plus Y is equal to 180. So you would show that all 3 of them is equal to 180. So you're going to say Y is equal to 180 minus, it depends on how fast you could move. The more you show, the stronger your chance of getting full marks. And even if you make a mistake, everybody understand me? So if you show that this is what you're doing, you maximize your marks. So you know you got 180 minus 108. So what is my answer? 72 degrees. All right. What is the reason? Angle formed in semicircle is 90 degrees. And all angles in a triangle, because remember, it's those 2 rules we use there. We use 2 rules. We use the rule, let me go back. We use the rule that this angle is 90, which is the angle in the semicircle. Then we use the rule that all 3 of them must add up to 180. That's why we subtract from 180, okay? So all angles in a triangle add up to 180 degrees. So that's our next 2 marks there. Again, I go back to my picture. Since I know that here is 72 degrees, I put it in the picture. Next one, Z. Anybody could tell me what Z is? Does Z need any calculation? What is Z? Based on what we spoke about before. It is also 72 degrees. Why? Because angles form on the same chord, the twin angles. No, just a heads up. Remember, in the exam, you can't say twin. That's a Miss V thing, okay? So do not, again, I repeat, guys, hello, do not put on the paper twin angles, okay? Because the man them not gonna know what you're talking about. You see it? So I just do it so that you can remember, but make sure you learn the actual theorem, which is angles on the same chord, okay? So Z is simple. Z is equal to 72 degrees because angles, and you could even say Z is equal to Y, okay? Angles formed on the same chord. Excellent. Corresponding is a good word to use because it means that they're equal or corresponding. Okay. Excellent. So guess what? That's the first part there. How was it? Was it manageable? You see, if you do it the way I did it just now, you see how easy it is to make the connections? You look at the picture first. You take each question step by step. Okay. Don't even look to see what it asks you for next because it's going to overload your brain. All right, next question. Anybody know what topic is this? This topic is bearings. We know what has come a lot with bearings. What are the topics that come with bearings? And this is how your mind should be working. You're either using one or two things. You're either going to use what? The sine rule. Everybody remember that? The sine rule, or who else? In the cosine rule. Sometimes you would use the Pythagoras or trigs, but when do you only use that? Only when you get what? A 90-degree triangle or right triangle. When you look at this picture, do we see any right triangles? Nope. So you should mentally prepare yourself to use the sine or cosine rule. Do we remember the difference between the two? One of them, you use it when the angle is in between the two given lines. Which one is that one? Which one is the one where we just use the angle falls between the two given lines? You got to remember these things. Excellent. The cosine rule. It's the cosine rule. The cosine rule is the one where you use where the angle falls in between the given set. So let's just look at the picture, even without anything. Look at this here. You realize how we got 12 and 18 and this angle in between here? Talk to me. Everybody see that? If I want to find this line here, I know what should I use? What should I use? The cosine rule. Everybody with me? Check this triangle now. Look at it. Watch where the angle is. Suppose they ask me to find this line over here. Do I use the cosine rule? No. I gotta use the sine rule. So I hope y'all seeing the difference even without us looking at the actual question. Okay? Another thing I want to point out is this is a point. Anybody remember angles at a point? All of them does add up to what? I kind of give you a hint here. What shape is this? A circle. So all of it would add up to 360. That's just general knowledge, okay? All right, so let's jump into the question. Now, these questions are tricky. You know why? Sometimes they give you the picture with all the information, and sometimes they would tell you something up here that they didn't tell you here that you have to add. So always make sure that the information in the statement matches the diagram. So there we go. The diagram below shows straight roads connecting the town L, M, and R. So that's 4 towns, 4 different locations. LR is 18. So let's look to see if that's there. LR 18, that's there. LN 12, let's check. 12, LN 12, good. MN 10. MN there 10. Angle RLN. And let me ask a question. Everybody understand how to read angles? We know that the angle is always located at the point in the center. Okay, we follow along each letter that would create the actual angle. All right, so please make sure you have that correct. 2, an angle LMN. So let's back check and make sure we have these angles. Another thing I need to make sure, how much digits do you write a bearing? Because that's another thing students just get wrong. Understand the difference between when they give you an angle, and they just do that all the time to confuse students. They give you the angle. Sorry, somebody trying to get in. Let me just send them a message. But take a look at the picture in the meantime. Start getting your brain working towards the question, because we're going to zoom through this quickly. All right, so let's go. So basically, from the image, we can see that all of the necessary information is here. Okay, so let's look at the first question. Calculate angle MLN. Let's look for where that is. M, yeah, M. Oh, I'm just going back through this question here. So yeah, sorry, let's go. It says calculate angle MLN. MLN. N. So that means this angle here. What rules we said we had to use for this one? Anybody remember? Very good. That's the first thing. Do not ever get confused. It's only two options you have, guys. Remember, when you're doing bearings, you're generally going to either use sine rule or cosine rule. Don't go think about nothing else. Unless you see a right angle triangle, obviously. Okay? And you know the difference between the two. So, we know the sine rule. Luckily for you, if you don't remember it, it's on your formula sheet. So, even if you remember it, you're going to know it's going to be A, which represents a side, over sine A, which represents the angle. B, which is side B, over sine B. Now, which one we just always try to start off with? In the two sides that we have. Now, look at this triangle. Which two pairs we have? Don't we have 88 and the matching side 12? Because we know if this is side A, this is angle A. Everybody with me? Talk to me and confirm quickly, because this is the basic stuff that we did already. So from here, what you are required to do, all you got to do is substitute. Now let's look at it. We want this angle, but we have to make sure we got a side that match it. Do we have it? Yes, we do. So we have 3 out of the 4. You realize there's 4 things here, and you got 3 out of the 4, which means you could find the missing one. So let me go. What should I write? It's always the side over the angle, sine the angle. So what is the side? 12 over sine 88. Everybody agree? Please get your calculators ready. Next one, do we have sine B? Yes, because it's going to be 10 over sine B. So before I continue, everybody understand how I reach up to this point? Let me know, because this is the easy part. From here, you should not make any mistake, because all this is calculations. So let me go. 12 over sine 88. What is sine 88? Thank you. 0.9993. I love the decimal places. Equal to 10 over sine B. Next step. What is the next step from here? We divide so we could get one value. So let me go. 12 divided by 0.993. You should be able to get like, wow. Very good. So we're going to end up with 12.0084 is equal to 10 over sine B. Now my question is to you. The thing that you want, when it is in the denominator, what do we do? What's the next step here? Excellent. We just switch these two things. So sine B, please understand that this is a special case when the variable or the missing term is in the denominator and you need to make it the subject, okay? There are videos I posted explaining the long way, okay? So this is going to become 10 over 12.0084. Let's go calculate, people. What is this going to be equal to? So sine B is equal to what? 0.8327. Also, I need people to verify. So even if one person do it, I need more people. This is 3 weeks before exams. Everybody should have their calculators out. I need to see more people sharing your calculations. I need to sleep when night come. I just can't sleep because I just be thinking, Jesus, how are these students doing? I don't know because they don't talk. So let's go. From here, so thank you guys. From here, what do we do next? Did they ask us for sine B? No, they did not. They asked us for sine B. So to get rid of the sine, we do sine inverse to both sides. Okay, so B is equal to sine inverse. Calculator people get to work. 0.8327. So B is equal to, but you see, is it 56 km? They ask you for a side. What did they ask you for? Angle. And I'm going to be honest with you. Anytime you use sine inverse, cos inverse, tan inverse, that is change length 2 degrees. So it is going to be 56 degrees. Hello, everybody. Everybody follow how we just got that? What is a general check that that is correct? What would tell me that's correct? How much we got? 56? 56. What tells me that's kind of correct? We know that this is so far looking like the longest side. And so this must be your biggest angle. So because 10 is less than 12, this angle must be less than 88. If it was bigger than 88, you know you're gone wrong. Everybody see what I'm trying to show you? Remember, there is a relationship between the sides and the angles. The biggest side faces the biggest angle. The smallest side faces the smallest angle. All right, so we're good to go here. So everybody see how we use the sine rule in this example to find the missing angle. So let's look at what is required of us for the next one. Calculate distance NR. I know that was coming. Wasn't that one of the things we looked at the beginning? Everybody remember that? When I asked you if you were to look at what sign, what rule to use for this second triangle, we identify it was what? The cosine rule. Agree or disagree? And why do we use the cosine rule? They gave us two sides. And the angle they gave us is in between the two sides. Direct one time, cosine rule. Okay? So let's be real. The cosine rule very, very long. Sometimes I myself forget it. So let's see if I could remember it from scratch because I already got a headache. I think a square is equal to b square plus c square minus 2bc cos a. Talk to me. That's it. You should be able to tell me if it's that. Is that the answer, my peoples? All right. Now, this is where we come down to the substitutions. All I'm going to do is substitute quickly so we could move along. So we want a square, which is this side, the missing side. So b square and c square would just be the two sides they give us. So that would be 12 square. Calculator, people, plus 18 square. What was the angle? The angle is 25. So let's zoom in now. We got everything we need. Minus, put back a squared to remind you that at the end you have to square root 2 times 12 times 18. I'm going to tell you the truth. Tonight, I'm going to work out this one question, but after, I'm not going to work out every single cosine question. Everybody understand what I'm telling you? Because once you understand what you need to do, everybody should be able to take it from here. Agree or disagree? So I'm not going to go through working out the answer for none of these questions moving forward. Similarly, the sine rule, I'm not going through it. Once we identify the sine rule you got to use, I expect you to know how to move forward. If you know you're not confident, practice it. Similarly with this. All right, so let me go through. We know that this means some things. 12 squared, 12 times 12. So that's 144. Plus, what is 18 squared, somebody? So far, I'm just going to put minus 432. I get two answers. Which one? See, that's why we need more than one person. So because we need to support each other. Thank you very much. That's 324. Minus, what is these three? How much things are multiplying in the back here? Let me see if y'all know what's going on. How many things are being multiplied here after the subtraction sign? Kayla said 3, Janella said 3, Jerome said 4. It is 4. Look at it. 2 is 1, 12 is 1, 18 is 1. Remember when you put cos 25, remember this means times, you know. Remember in maths, when things are next to each other, there's an operation in between them. This means times. And remember, cos 25 have a value in the calculator. When you put a t in the calculator, it's a decimal. So it's 2 times 12 times 18 times whatever cos 25 value is. Okay? So there we go. I'm just going to rewrite it so it's easy for us to multiply. So you write back 2 times 12 times 18. What is cos 25? My favorite thing to see is when I see oh, because that make me feel like, yeah, people, things clicking. Excellent. 0.9063. So what do we do in BODMAS? We always do what? We multiply first, right? So you see, don't go be wild and never plug all of this in your calculator. Never. Step by step. So let's go. Multiply all 4. Tell me what you get. And another thing is, the reason why I push you guys, you got to know how to calculate fast. Let me go. You got to be able to type it in and then even type it in again to back check. You have to move fast. Okay, so I see 99391.524. I'll take the 3 decimal places. And then you could always add these 2 together now. So add those 2 together for me, please. This is the only way to avoid mistakes. Once you understand this basic approach, you should be able to handle it from here. So it's 468 minus this. So what is this my final answer? No, it is not. That's just a square. So what is a square when we subtract it? Okay, 76.4748. I'll just take the higher one for now. So what is A? I like the 4 7. I always like 3 decimal places until now. What is A? How do we get from A squared to A? Anybody remember? We square root, because when you square root both sides, the square is cancelled. So A is 476. Let's go, guys. What's the answer? So Jerome said 9 km. Anybody else? You sure? Now, my question to you is, why y'all gave me 9? That's what your calculator give you. They did not say to the nearest meter. Understand what I'm showing you? They did not say, and this could never be 9 because I know 9 times 9 is 81. This number is not 81. So there's no way that should just be 9. Everybody following? So I expect a decimal number 8.745 km. Everybody with me? You only round it up to a whole number when they say to the nearest meter, to the nearest degree, to the nearest whole number, to the nearest, that's the only time, because you would lose a mark there for that. All right, guess what? We got one more question left. So let's put in the images that we have. Oh, I love this. Determine the bearing of town R from L. So look at this. I'm telling Aya what to do. Look at this. They want the bearing of R from L. Let me see who thinking. What's the answer? What do we do? The information right there in the picture, which is why I always encourage you to write the answers in your picture. So I would write 8 point whatever I get here. Jerome say add. Add what? So for the interest of time, let's just say 90 and 25. Where you get 90 from? Look at what does a bearing mean? Everybody remember what bearing mean? Bearing is from the north line to the line of the letter. So look at the line for R. Look it right here. So the angle between the north line and the line to the R, ain't 3 angles in between now? Talk to me. Everybody seen the 3 angles? Where are the 3 angles? Look at here. One is 50. One is 50 that was given. We found the 56 and the 25 was here all the time. Everybody see the connection now? Talk to me, because this is how these questions has come a lot. And as we move forward, I expect you to see and to look for these things. So our working is 50 plus 56 plus 25. You see why it's just one mark? Hello? Because they expect you to know to just add them three. So 50 plus, what was again? 56 and 25. 56 plus 25. Why I say 131? Remember, don't forget your degrees, your sign. 131 degrees. All right, so for the first question, how was that? Was everybody okay with following what we were supposed to do? Because I'm going to be honest, question 9 is always poorly done. But if you really mentally prepare yourself, you can smash that. And you see, if you could smash question 9 and 10, you're pushing yourself to a better chance to get a 1, a 2, or a 1. I'm being honest. Okay? All right, so let's move on. The next year, I'm going to go a lot faster. For some strange reason, the thing disappear again. Let me see if I could get to pop back up. I don't know. So we're going to skip that one for now. January 2021. We're going to come back to it, okay? So I'm going to zoom through this question a lot faster. Okay. I'm going to highlight the first thing I see. I see in some Zs. I see in backward Z, the alternate angles. Talk to me. So I know this angle here equal this angle here, the whole thing, eh? Be careful. Don't get confused by this 68. Similarly, if I got front Z, I got back Z. Please, if I miss anything, let me know. I'm holding on for dear life. So I see here another alternate angles. Good. So let's see what else we see. I see the external angle. Excellent. The cyclic quadrilateral. Watch it here. Everybody see now? That's a cyclic quadrilateral. Another thing is, do we see the cyclic triangle? And do you see the tangent? So what do you also realize? The internal okay. What else y'all seeing? Anything else before I miss? Oh my God, yes, the angle on the diameter. Very good. I nearly ain't see that one. Look at this. That's the diameter. It's on both sides as well. Look at this. What does that mean? What angle is this here? The 90 degrees. Everybody see that? And look on the opposite side as well. So that means this angle here is 90 degrees too. Yeah? Excellent. Excellent. The chord and the radius. Very good. This is the radius. Very good. And this is the chord. So what do we remember? We know this whole thing here is 90. This whole thing here is 90. Everybody with me? All right. I think that's it, right? Yes, it is. You know which line is not a tangent? Look at it. That ain't a tangent. Look at it in the diagram too. The tangent AEB. Everybody see it? This one up here is not a tangent. This one is not a tangent. So that's the one you gotta be careful. That is not a tangent. Also, anybody seeing the supplementary angle? Angles on a straight line? CF is the chord. All right, so let's jump into the question. Okay, give me 2 minutes. I literally have like a pulsating migraine all afternoon. Okay, so I want you guys to take a look at this one and let's see if we can find it together. Angles ECD. Be honest, can you find where the angle is? ECD? So let's see where ECD is. ECD, follow it. ECD, that means this angle in between here. Now this question is way harder than the one before, but it isn't that hard, to be honest with you. Anybody knows what that angle is? How do you find that angle? Is that a direct or indirect question? I seen a Z. Is it the external and internal? I ain't seen the Z. Anybody seen the Z? Look at it. So if here is 68, look at the Z. Remember these two lines parallel. So if here is 68, what is here? Excellent. Everybody following now? See how easy that was? Remember, you got to pay attention. Look at it. Open your eyes. Okay? Don't panic. So I know that ECD is equal to 68 degrees because alternate angles are equal. If you want to get extra fancy, identify the angle. So I would say angle, what this is, AEC equal to angle AEC. That's if you're feeling extra confident, you got enough time, all of that good stuff. Okay, let's go. So I'm going to put in my diagram 68 here. You realize I'm putting in my diagram, boom. Next one now. Calculate or find CEG. There we go. Where's that? CEG. Where's G? Oh, look at here. So let's look at this now. CE. Man, not easy. Everybody seen it? CEG. That's in between here. That easy. What is that? How do I find that extra piece there? Everybody should be able to tell me. What do I do to find that? Look right next to. Excellent. Tell me if I've seen it. Because we know this is the angle between what? The radius and the tangent. What is the rule about the radius and tangent? That both of them together add up to 90 degrees. So if here to here is 68, here is going to be 90 minus 68. 90 minus 68 degrees. So 22. What do we call that? Angles in between what? Between radius and tangent. Is 90 degrees. And both angles are complementary. What complementary means? 90 degrees. Both angles are complementary. So I'm just going to plug in my picture here, 22. So in between here is 22. Yeah? Next one, CGF. Let's go. CGF. How we find that? Anybody have any ideas of what we do to find that? So look what it is. CGF. Anybody seen anything yet? I myself am currently looking. How much marks this is? This one seemed like a big one too. No, I have a way, but it's a long way. Y'all want to hear it? Guess which rule I'm gonna use? I would use the cyclic. I would use the rule is cyclic, the cyclic quadrilateral. Let me show you why. If I know this side, can't I find this side? Be honest. Shouldn't I be if I find both of them, what do I do to find this one? A, subtract it from 180 degrees. Let's call it A. Everybody following the logic before I start? I want to make sure you understand what I'm trying to do. I know that I could find this angle if I know. And you realize you always sometimes use the thing you find before. Talk to me if you understand how. Let's say you reach a point and you're stuck. Highly likely the thing you find before, you're going to need it to find the next question. So don't be afraid to experiment with it. No, but how do I get this? Don't I know this? Can't I find this? These two angles in turn co-interior. Talk to me, they're in co-interior. So if here is 106, what is in between here? In 180 minus 106. Let's go. So what is that? 180 minus 106 is what? 74? No, if I know here is 74, just how we find this 22, how do I find this piece in here? What do I say? 90 minus 74, right? And you get what? 16? So this entire angle, so I'm going to put 16 here. So this entire angle here is what? $38? What we get? Remember 16 plus 22 and 16 plus 22? How are I getting these numbers, guys? 38, right? Okay, good. So that means this angle here is 180 minus 38. Tell me how much you get. So that one is a hard one. I wouldn't lie. Not the average student would be able to figure out all of that, which is why I wanted to make sure you take some time to find it. 142. Now, what do you do to get that? How do you do that together? You realize all the space you have. First thing you're going to say, find, what's the first thing we found? We found angle FEB. So write it down. Angle FEB is equal to 180 minus 106. Just show you're working, to be honest. Every angle you find first, just show you're working. Okay, that's a form of explanation. And then you're going to say, hence, that's the part that connects it. Hence, angle, what did we find next? GEF. Hence, angle GEF is equal to 90. What was again? How much we got here when we subtract this? 74? Okay, good. 90 minus 74. And that's how we end up with 16. Then you're going to say, therefore, just use these words, guys. Hence, therefore, as a result. So therefore, watch it, CEF is equal to 22 plus 16, which is equal to 38. And you're going to say, this is the most important part, which is opposite to CGF in the cyclic quadrilateral. In cyclic quadrilateral. So let me pause here. Everybody understand how I wrote this down and broke it down? You realize all I'm doing is just showing my calculations and showing them, I start off with this, I get that. Okay? And I'm going to be honest with you. You got another way to find it. I just too tired right now, but it's just a way you could find it. Don't be afraid to experiment. Okay? So we know, since we know that it's opposite, you could therefore again, or hence, CGF is equal to 180 degrees minus 38, which is 142 degrees. That one was a little stiffy there, but we did it. We did it. Okay? How everybody feeling about this one? Especially looking at an example that was extremely complicated. I hope you see how you should approach it. Don't panic. It is a way. Think of it like a challenge, like a puzzle. Find the pieces that you need. Sometimes you need to find something first to find the answer that you need. Make up your mind to look for it. Don't give up. There must be a rule that you could use to get something to help you find the answer that you need. All right. All right. Okay. So let's continue. What do we have here again? What topic is this? What topic is this again, guys? Bearings, right? As we see here, this is a little tricky. You realize that the picture look way emptier than the example before. So I hope you realize that you see sometimes they give you all the data and sometimes they don't. So let's look at the picture. You realize they got angle, so they didn't give us an angle here. That's the same thing I was telling y'all before. Always read and insert accordingly. From I have a H, good. The bearing of two ships. So that means it's two bearings. Let me show you. This is the first bearing. That's the ship Q. And where's the second bearing? Straight over to R. Everybody see that? Hello? Make sure y'all are live, you know. Let me go, let me go, let me go. We got to push it. All right. So let's go. So we have Q and R, the bearing is 069 and 151 respectively, sorry. How would you draw that picture there? Would you put 151 here? Talk to me. Would you put this like that? Guess what? That's wrong. You know why that's wrong in the picture? This telling me that this angle in here is 151, and that's not true. Talk to me if you see what I'm saying. Everybody understand what I'm saying? So in reality, you should take a pencil and draw an arrow coming straight down. So you know that this whole entire thing is 150. Now let me ask this question. What is this angle in here then? What would you do? Excellent. Lysandra to subtract, Martha to subtract. Everybody see that? Yes. So because of the person I am and I know how my brain works, guess what I would do? Just to be safe, I would subtract it, which is how much? How much you get? 151 minus 59. I would just plug in here that this angle in here is 82. And then outside here, I would just put 151. Everybody check what I'm trying to do? That's how you're supposed to operate. And I love that this was the second example so that you see the importance of inserting this data into the diagram. Thank God they ain't making I draw any, but if they ask how to draw, we don't do some practice. So for those people who didn't attend the drawing class, the video is uploaded. Get at that. All right, what other piece of information are we missing? Q is 175 kilometers from H. Q 175. So this line has a value. Let me put it in black. So how much is that? 175, 175 km. Put in everything, because look at that now. What rule y'all seeing so far in that triangle there? Which rule you seeing now? Everybody seeing it now? You got two sides and the angle in between the sides. And the same thing like what we've been doing before. Hello? Talk to me, make sure you're seeing it. Oh my God, look at what they say. Complete the diagram to show the information given. Look at that. Hello, everybody got it? And guess which one they ask us to find now? QR. So we know what to do. What's the first thing you're going to write? Cosine rule. A square equal B square plus C square minus 2BC cos A. You know what B is. What is B? B is one of these distances, C is the other one, cos A is that, and we know how to substitute and solve. Everybody with me? I'm moving along. I got 19 people up in here, and I need everybody to talk to me, talk the things. That's right. Remember, it's all about making sure that you understand what to do. That is students' biggest problem. I am not afraid that y'all gonna be able to calculate. My fear is that you're not gonna see what you should use to calculate. Yep. What do you mean? So teacher, HQR. HQR. 6. No. Remember, they asked you for QR. That's the distance, the line, this distance here. From Q to R. Okay? You with me? All right. What are you talking about? Remember, it says here, the bearing of two ships, Q and R. So that means, respectfully means right after the other. So this is the bearing of Q. This is the bearing of R. Look at where R is. You see it? And don't ever be afraid to reread it to make sure you're clear on everything. All right? Okay, good. So guess what we're going to do now? They say calculate how far south is the ship R from the harbor H. So which distance we looking for? Hey, let me read that again. Calculate how far due south is ship R of the harbor H. Ship R, harbor H. Oh my God, guess what I want you to do, guys? Let me see how much marks this is. 2. Anybody realize what they're asking for? Look at this here. What south mean? Anybody know what south mean? South mean how far down from H, that distance there. No, look at this. Look at this now. Oh my God. Look at this. I'm going to use dotted lines for this. Hello? Oh, I seen this? What type of triangle is that? So which rules we should be thinking about right now? Everybody see what I just do there? Oh my goodness. This was like a fire question. You see why the reading comprehension part is the difficult part here? How far due south? It means how far due south. They ask you for the angle because they don't give you this. So they want to know how much due south is R. That means they want this line. So let's call this X. Based on what we know, what line would HR represent? Wouldn't that be the hypotenuse? The hypotenuse. Excellent. And then what would X be? We don't know yet. We can't say opposite yet. But let me ask this next question. Which angle here we could find? Let me see who's thinking. Look at that line from the north line, go down. Can't we find out what this angle is here? Let me use a different color there for I, you see? Let me see who's thinking. Isn't this a straight line? We know from here to here is 151. What is this angle in here then? All the angles must add up to what? Not a right. What is the angle on a straight line? The angle on a straight line is 180. You realize this is a complex question here? Everybody understand what you should be doing and thinking? You have to use what you know to find what you need. So the first thing you should say, I know this is the hypotenuse, but being at an angle, but they expect you to know how to find this angle. That angle in between there is 180 minus 151. How much that? 29? That's it. Don't we have a right angle triangle now? Now we could determine what side X is, because now we know X could never be the opposite. Everybody see it? X got to be what? The adjacent, because it's next to the angle. What ratio uses adjacent and a hypotenuse? Think about it. Look at it again. And I'm going to do this for y'all to remember. Don't forget this. It got two ratios that use hypotenuse as a denominator. Two of them. One, opposite gonna be the top and adjacent gonna be the top. Sine is the one with opposite to the top. Cos is the one with adjacent to the bottom. Then you got one with only opposite and adjacent, and opposite is always on top. And who is that one there? That's the tan. Everybody see that? So you know, once you're dealing with hypotenuse, it's either cos or tan. If opposite is on the top, you know it's sine. If it's adjacent, you know it's cos. So we know we're using who? We're using cos. There we go. Should I need to do this? I shouldn't need to do this. I will just write it out first. Cos theta is equal to adjacent over what? Hypotenuse. So you substitute cos. What is cos theta? 29 equal to x over hypotenuse, which is 242. Let me ask this question. You should be able to take it from here, right? Hello? Everybody be honest. Everybody, can you take it from here? Just because I want to make sure. I'm going to do this one and I ain't going to do no more. Cos theta, cos 29 is a value. Let's go. What's the value of that? So you find the value of cos 29. You put it in your calculator. You get your decimal. There we go. We ain't taking nothing for granted. We're going through everything at least once. So I have 0.8746 is equal to x over 242. In this example, x is at the top and something is dividing x. So we know this is not a switching example. Everybody see why it's not? Because x is in the thing. So we got to multiply by 242 to cancel this 242 to the bottom here. Whatever you do to one side, you do to the other side. So x, because this and this going to cancel, is equal to 0.8746 times 242. I don't care about the actual answer. I care about everybody understanding why we did what we did. So everybody, let's go. Talk to me. We finish our next past paper. That's a whole next past paper. How you feeling? Everybody see how manageable this is? If you understand what you should be thinking. The hardest part, I'm going to be honest, is this last one here. Because if you don't know what due south mean, you would get confused. You just got to remember, these coordinates have angles. So let's go. Let me just make sure I show y'all something. The north line, everybody know what the north line is, right? Straight up, right? If something is due east, what does that mean? What angle is that? If you're going straight east, oh God, sorry. Let me use yellow. If I go east, I should know that as well. What is the bearing? The bearing is 90 degrees. Sorry, 090. Let me don't make that mistake, okay? Everybody see why I put 090? Because it's a bearing. Let me go. If my bearing is south, I'm not going straight down. What angle is that? 180, exactly. If my bearing gone west, let me see who thinking. What is that bearing? Ooh, look at you guys. How do we know it's 270? Because you got to add up. This is 90, this is 90, this is 90. Remember, you got to go straight around. You remember, you're starting to calculate or measure your bearing from the north line. So from there to there is 90. From there to there is 180. And from here to here is 270. I'm so proud of you guys, to be honest. I want to cry. Oh my God. All right. So a lot of things we revise here. Trig ratios. Look at how they made the trig ratio come into a question like this. When we thought that, you know, cosine and sine rule only. All right. Y'all ready for another one? Are you guys picking up the patterns as well? So let's take a quick second to just answer some questions. Are you picking up the patterns, especially with the bearings? For now, I'm going to skip this because I want to do this one. Anybody remember this topic? What does it look like? Because you had to draw it in your books, so you should see it. What is this? Angles of elevation and depression. Excellent. So, how much triangles y'all seeing? Anybody seeing the two triangles? And do you notice that? What do you realize about these two triangles? They both share the same height. You realize that? So I could separate these two triangles as two separate drawings, same height, but they both have what? Different widths. So one gone like this. And if you need to separate them to make a calculation, don't be afraid to separate them. Same height. But one stop there and one gone. So everybody agree? Hello? So we're going to skip this one from before because this is just another, as you see, maybe I might do the circle theorem and skip the bearings because all bearings, honestly, similar. Because as we see here, we notice what? Oh, this one a little tricky, but okay, I want to do this one. What y'all think? I think we should do this one. Anybody seen the co-interior angles? Turn your head to the left, like lean your head to the left. You should see the Z. Look at the two knot lines is what I'm asking you to look at. You gotta see these things, eh? So turn your head tilted to the left. You're gonna see the Z. The forward Z and the backward Z. So you should see the co-interior. So I'm gonna show you where the co-interior be now. This is one, because look at the parallel lines, right? These would be the parallel lines, the knot lines. So this angle in here and this angle in here in the co-interior. And that means both of them must add up to what? Those two angles there must add up to 180. Everybody see that? Another thing, which rule you're seeing so far? The sine rule or the cosine rule? So suppose I ask you to find this line over here. What you got to use? Cosine, right? Everybody see why? Why do we use the cosine? Look at the position of the angle. It's in between the two sides. Everybody following? I hope you have seen it, you know. These are the things you gotta be looking for. Whether if it's a sine or cosine rule. Now, let me ask you this question. We know this angle in here because we don't know how to find it. How do we find this one though? What should you do? What do you know about all three of these angles? All of them are on what? What is this? They're in a straight line. So all three of them must add up to 180. So we don't know how to find this because we know this and this add up to 180. So we say 180 subtract 133. That's how we find this. Everybody realize that? They're going to ask you to find this. They're going to ask you to find W because what they expect you to know is that to find W, you need this one up here. Everybody following me? I know it's a lot, but I just want to make sure I go through the content, the concept of thinking. Me going through this question because it's the same thing. Cosine rule, blah, 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 blah. Okay? Let me ask you, suppose they ask you to find the bearing of R from P. What do you need to find that? You know the bearing from here to here. So to find the bearing from here to here, what do you think you would need to find? In this angle in here? So let's say we found the angle side. Let's say this was 300, just in case. What rule would you use to find this? In the sine rule? Because we got these matching sides and we have the side for this angle here. So you would use the sine rule. So I hope everybody see what I'm trying to show you. It's the line of thinking that's important. So we're not going to go through this one because you see, look at that. Find RP, find the distance RP. That's the cosine rule. Find angle W. We know how to find W. Determine the, oh, look at that. Same thing. Determine the bearing of P from Q. Where's that? P from Q. That ain't easy. How you do that? Let me see if anybody thinking. Look at the image. This is from Q. P from Q. What do you do? Let's say this was 40 here. We find W already. What is the bearing? Isn't the bearing all the way go around to this line here? What is from here to here? Excellent. So this side is 180. So to find the entire thing, what do you add? The 180 plus what? The 40 plus what? The 56. If you got it, say got it. Let me erase all of this shenanigans. If you don't got it, most importantly, say don't got it, eh? Don't be afraid. Part the things. All right, so we're looking good so far. So let's, oh my God, I done turned my head upside down. So every single circle theorem question we're gonna do. So we got 2 more. Let's look at this one. Everybody feeling okay? I really wanna know if, are you feeling stressed? I hope you're not feeling stressed. I hope you're feeling like you're feeling better, you're feeling more confident, you're feeling like you're strengthening your understanding. I hope you're feeling pumped to like, yeah. No problem. Oh, this year is 2020, January 2020. Okay, I like that. I'm really hoping that it's really helping you to, clarify and show you what you should be looking for and all these things. Okay, so let me go, guys. We got a lot of things going on here. I see 2 types of triangles. So let's look at the rules that we see. Okay, first thing first, I see an isosceles triangle. What do I mean? This is a radius. Let me use yellow. This is a radius, and this is a radius. Everybody see that? Yeah, I have a headache too, but we're gonna tug it through because that's what tuggies do. You know what I'm saying? That's what we do. So I know to even go around exactly. I know we know how to find x, because if these 2 sides are equal, it means these 2 angles equal. Talk to me. Talk to me. Isn't that true? So I would just use my pencil and I would just chuck in this one time. I ain't even sticking. I ain't even waiting until I go to the question. I know I can just chuck that in one time. So I don't know what x is. I don't know. How do we find x? We add these 2 up, right? And subtract it from 180. Yeah? Okay, good. What's the next thing are you seeing? Anybody seeing the diameter rule? The 90 degrees, the angle on the diameter? So we could find y easy. Everybody see that? Because I know this is going to be what? 90 degrees. And again, we got 2 angles out of the 3, so we could find y. Let me see what I try. Write down the mathematical names of the straight lines BC. Oh, I like that. What's the name of BC? Let me see who remember. What do we call BC? What's the line called BC? Excellent. Excellent, guys. Very good. Card. Very good. What's the line OA? Nobody should get that wrong. What is OA called? Excellent. Radius. Just like that. Free marks. Free marks. We know how to find X already. Agreed? We know how to find Y already. So guess what? That's just it how we done this whole entire exam. Yeah? Without going through everything in detail. I know you was overthinking. You just stress yourself out so much. Stick to the basics, okay? All right, so let's get into this question, which is what I really wanted us to do. And I think this is the last, only one more paper after that, yeah. I just wanted to do May and then we're good. And that's the last of class. What time it is now? I have no idea where my phone is. So we at 7:33, an hour and a half in. Okay, everybody ready to go? Let me know if you're ready to go. We get in there, we get in there. The more practice we see, the better we are going to be. Trust the process. So type ready if you're ready. Because I'm gonna be honest with you, I expect y'all to rip up question 9, man. Like no crumbs left behind, man. Like when you open a paper, why take a deep breath and just pace yourself. Attack everything that you know you're gonna kill without being afraid. That's what you want to do. You want to finish what you could finish as fast as you can, and then you go back to the questions that you're not as confident, and then you sit down and you think. You think about the rules. You think about what you need to get done. So let's look at what we have here. Always try to read through the topping, the header, to make sure that everything that's up here is here. So just by skimming through, I see that the angles, both of them, they gave it to us. It's here. Sometimes they also tell you about certain lines that don't look like a line. So as we see, we have no diameter because you realize it does not pass through the center. We do not have any tangents. This is not an actual external angle, right? So we have a few things happening here, but I do see something. I do see twin angles. Anybody see twin angles? Let me show you where the twin angles at. Let me show you where they at. Even though there's no line connecting them, look at the beginning and ending points of these two lines. This angle and this angle start and end at the same place. Remember that? So just by looking, I know straight up from the jump, this is 75 degrees. So I can just chuck that in immediately. What is another thing that I should know? And look at it. Wouldn't this make sense? Look at this, the cyclic quadrilateral. Anybody seen it? It's two of them. Should I highlight it just in case so you could see? Let me highlight them. Cyclic quadrilateral. One side, two sides, three sides, four sides. But you see that? Okay. Next one. One side, two side, three side, four side. Anybody realizing something here? You realize both of them sharing the same opposite angle, which would make sense. So even if you choose this one, you realize the opposite angle would just be what, 180 minus 75. Everybody see that? And even if you use this one, you would still get the same answer. Hello. Okay, good. So let's take a look. I don't be afraid when I start singing, okay? This is just me trying to give myself energy to like tug it through, okay? Yeah. So let's look at the first one, PTR. PTR, we don't find it. Oh my God. So we know we just put what? PTR equals 75Y. Angles on the same chord are equal. Everybody see the strategy and how it helping? Be honest. Doesn't it help a lot when you come to the question? It makes it so much easier for you to see what you need to see. Next one, angle TPQ. Where that at? TPQ. So let me erase this here now. So let me put this angle in here. What was this here? What was this here again? What was the answer? We know that, wait, let me go again. What's the thing? TPQ. Let me go. TPQ. That's this angle here. No, nobody never teach us this, right? But I'm gonna tell you the truth. There's an indirect way of finding this angle. You see, you think they put the 60 here for no reason? So how do you think this angle gonna help us find this angle over here? Oh. And I'm gonna be honest with you. You see how they have external and internal angles with the triangle? There's something called the external and internal angle with the quadrilateral too, by the way. So I'm gonna tell you the truth. This external angle is equal to the internal opposite. So in here is 60 as well. But guess what? I'm gonna do it the long way. But everybody see what I just show you? The external is equal to the internal opposite. Remember, this is the internal opposite. It can't, this could never be the opposite. Why? Because it's next to it. This could never be the opposite because it's right next to it. Everybody see the difference between what opposite looks like? So please make sure you see and understand what opposite look like, okay? So let's do it the long way though. If out here is 60 degrees, this is in a straight line. So if I find the internal angle, this would be 120. And we know why. This is a straight line. Angles on a straight line is 120. So if this is 120 and this line, this angle is opposite, opposite angles in a quadrilateral are supplementary. So the long way would be 180 minus 60 is 120. And then 120, 180 minus 120 is 60. Literally. So this is, I won't say something new, but it's a new concept to kind of keep in mind as well. Just like how you could have external and internal angles with a triangle, you can have internal and external angles with a quadrilateral. So that's the answer. Yeah? Obtuse angle PQR. Obtuse angle POR. Where's P? POR. But there's no, oh, look at what they do. I never see this before. Anybody realize what I just do here? They're asking you to find it without giving you the actual center. Anybody realize what's going on here? So it's not in the picture. They're asking you for an angle that's not in the picture. But guess what? We smart. So if we were to have this here and they want P, let me draw it with a straight line so you could see. Everybody should be able to tell me what answer is this. POR. What does this mean? This ain't angles at the center. Hello? I never see this before. That's the first time I ever see this. So I'm glad that we see it so that we know it's possible because I did not know that they just do this. So what would be the answer? 210? How you get that? Ain't 150? Angles at the center is twice angle at the circumference. So if this is 75, the angle up here, remember it's at the same point. Here would be, that's okay. That's why we're here. So this would be 75 times 2. 150. Everybody got it? This was a pretty easy one, to be honest with you. I hope to God I get something like this. I would smile. But I feel like y'all would be able to handle challenges as well. All right, so let's go on to our angle of elevation question. And I'm going to be honest with you. Once we do that, we should be good to go. This is the last exam. I just want to listen, even if it's bust head hard, we are thuggies and we don't give up. You know what I'm saying? We're going to keep trying. This is the question I was telling Aya about. You see how they put both questions together? They're so evil. They're so evil. Anybody see what they do here? So in this question, you could literally use a lot of things. You could use, my goodness. You got to think about cosine and sine. And you got to think about trigonometry and Pythagoras theorem. Now, Jerome, here's the thing about that, right? You can't just say, you know what, you can't say 90. They didn't tell us that this is a 90 degree, even though it looks that way. You can't use that because they're going to ask you why, who tell you that that's 90 degrees. You see what I mean? So don't ever do that. Don't look at it and assume if they didn't tell you. The only 90 degree that they tell us is this one up here. But the truth is, right? Because this is, did they say these two lines are parallel? Okay, yes. So because here and here is parallel, okay, you can. Because this is a perpendicular distance, that's the part I was making sure that it had to say that they're parallel for you to assume that this is 90. Because they're parallel, it is 90 degrees. So that's correct. You see what I mean? But you have to look, it has to say it. You cannot ever just assume that it is, okay? They just do that sometimes to intentionally mix up students. So let's go back to this question, and then we are going to wrap up right here. Y'all want us to do this one as the last one, just in case, because I feel like we should do this one. Let this one be the last one. So we're going to literally finish all the exams I had planned today. Wow, I can't believe we finished all. This is the first time we ever finish all of the exams. We only usually get through 3 or 4. Okay, so let me go. Don't worry, CXC bad, but we better than them. We not afraid of that. Hey, Miss V don't have no punks in she class. I don't know. If you're a punk, leave the class right now. Bust off. Okay, so there we go. Step 1. I stay hush. Step 1. When we look at this picture, we should know the topic already. The topic is angle of elevation and depression. And we know what topic does come under this. So when you see things like this, you know it's trigs already. Agree or disagree? Remember, this is how you're supposed to be training your brain. You see a question, start to figure out what you need. So you know in your mind is either a sine, a cosine, or a tan you're going to be using. Now, as we've noticed, you realize there's no information on this. So that is the tricky part now. That's the part where students go wrong because they're unable to translate the information from words into the diagram. So let's do that together. A person at the top of a lighthouse. So let's ask this question. Is it depression or elevation if the person is to the top? Remember, it's depression because if the person is at the top, they're going to be looking down. Talk to me. Remember, elevation is if the person at the bottom and they're looking up. Okay? So make sure, because that is something that will make you get wrong. Because if you put the angle in the wrong place, you see what I'm showing you? So that's why we got to pay attention to. Look at the position of the person or the object. The person or the object is at the top. So that means the person is looking down. Okay? So the person is at the top of the lighthouse, TB, sees 2 ships. So it's up here. This is where the person is. Let me just make sure I erase all of this so it's not confusing. So the person up here, this represents a person as a dot, sees 2 ships, S1 and S2, approaching the coast as illustrated in the diagram below. The angles of depression, you see, are 12 degrees and 20 degrees, respectively. No, I'm not going any further. I'm going to label some areas. So let me zoom in a little bit. And I'm going to ask, where would you put those angles? So here is A, here is B, here is C, here is D, here is E, here is F. Okay. And there could be more, because I'm going to tell you the truth. There's more. Because from here to here is A, From here to here is B. From here to here is C. But guess what? From here to here, I'm going to put G. Everybody see all the places that I label, all the different angles? Because my case right now ain't about doing no calculations. It's about making sure you understand how to translate the information. So far, I only got one yes. What am I them? So I'm going to chill right here until I see majority of people telling me that they see all the angles or where they are positioned, because you have to be mindful of all the options that you have. Okay. Now, let's look at the two angles that they gave us, the two angles of depression. What are the two angles of depression that they gave us? 12 and 20. Now, this is what you should be thinking in your mind. 12 is smaller than 20. So you have to know that the smaller angle has to go to be labeled 12. So we got two things we label in here. 12. So let's start off with that. Where 12 going? Let's go, everybody. If you're in an exam where you're going to do nothing, you have to decide, where would you put the 12? And that is why we're doing this question together. Okay, thank you everybody for responding right or wrong. Excellent. Now, let me remind you, where is the angle of depression measured from? Remember, it is always from the horizontal line. Whether the horizontal line is to the top or to the bottom, it's always from, just like the bearings. You know how bearings just come from the knot line? Your depression angle comes from your horizontal line. So that means we started from the horizontal line. So which angle is the smallest angle measured from the horizontal line? A and A. Look at it. Because here you would realize this is the first one. Everybody see what I mean? And see why it is A? B is not a depression. B is just the difference between the two depressions. Everybody see now? Look at it. So look at where the two angles coming from. So A from the line, so that is the 12. Everybody following me? No, what was the next one? B, what was the next one? The next one, yeah. Where would I put 20 now? Exactly. Everybody following? Exactly. That's what we're talking about. So this would be 20 degrees. And B would therefore be what? What would B be? Excellent. Even though we don't need it right now, you please know that I don't need it. I just want you to know what it is, okay? Everybody following? Now, let me ask even more importantly. Let me erase B for now. What is C? Let me see who's thinking. What is C? Excellent, Myrtle. Excellent. That's it, Austin. That's the reason. Everybody see how they got that? Look at this angle here. This whole entire angle from here to here is 90. So just like what we were doing before, if from here to here is 20, here to here is the difference, because both of them added together must give you 90. You see it now? So if here is 20, here must inside here is 70. Good. Now, just like how we get this information up there, what did we learn about angles of elevation and depression? Ain't the same thing. Look for the Z. It's two Z's going on here. Anybody seen the two Z's? So let me try highlight them, because that's how you're going to know how to label the bottom. So look the first Z here. Jesus. Bad man thing. So let me highlight the first Z. because angle of elevation in depression is all about the Z. So let's check it out. If A is 12, which other letter is 12? That's it, mi amigos comunitarias. Excelente. Muy bien. So here is 12. I hope everybody's seeing it, and not faking it. Don't fake it till you make it. If you're supposed to be confused, be confused. Here with me, no. All right, let's do the next Z. I am making sure I take my time and highlight this so you can see. So if this one is 20, so we know this one in here is 20. What is also 20? Excellent. So in here is 20. So my next question is, do everybody see the two different triangles? So let's label the two different triangles now. So here we have, what angle should be in here? 20 degrees, right? What should be here? 12 degrees. Everybody see that? So we would call this what? S1. And we will call this what? S2. If you know you're kind of getting confused, don't be afraid to go on the side and separate your two triangles, okay? If it helps. Sometimes it helps a lot. Because I'm gonna be honest, you think, do we care about this angle up here? After we get the angles to the bottom, do you know that's the purpose of this? The purpose of the angle of depression is to get the angle in the right angle triangle, you know? Let's be clear. After you get that, you don't really need them again. And we know, just for the purpose of knowing that here is 70 and here is 70. Everybody following the point? It's always about the triangle. It's always about getting the information for the triangle. All right, so let me go back up. They gave us some distance here. They said these ships are 110 meters apart. No, this is a great thing. Let me erase all of this now. Where would I put 110? So let me just put back in 20 here, 12 here. Where should I put 110? In between here and here? 110. Yeah? Let me put the angle here. So that's the information they give us, my good people. So let's look at this diagram now. Let's look at this question. So it's a complete diagram below by inserting the angles of depression and the distance between the ships. So you know, you would have put here 12, you would have put here 20, just so. And most importantly, you put it to the bottom here. Okay, so that's why you get full marks for that. Now, the distance between T and S. Now look at this. What do we have? Everything we need to find out? What are they asking us for? Let's look again. Find the distance. What? The distance. Determine TS1 between the top of the lighthouse. Determine to the nearest meter the distance TS2. Where is that? TS2. So this is what they want us to find. Anybody seen the tree? It's three triangles here. Anybody seen the third triangle? Be honest. Are you seeing the third triangle? They're saying a triangle in between here, a non-right angle triangle. Somebody said Jesus. Of course, once it has three sides. So it's not only important to see two separate right angles, you have to see the other non-right angles that form as a result of both of them. Everybody see that? Hello. Talk to me. Okay, good. Now, we want to find this line here. Let me just highlight it in green because we're going to end. This is our last question, okay? That's why I'm taking my time, because what students does usually fail with these questions because they don't see these things. So that's why I want to make sure your eyes open so you know what you should be looking for. Okay, look at the obvious and look at the non-obvious stuff. Okay, good. We know, right, that this is a non-right angle triangle. What two rules should come to our mind at this moment? What are our two options? We know our two options is the cosine rule and the sine rule. We need to determine which one we need to find. Now, if we look here, we don't have two sides. Everybody see that? We only got one side of that triangle, which is what, 110. So guess which rule we cannot use? We cannot use the cosine rule. We need to use the sine rule, but we only got one angle. So we need to figure out, how can I find another angle inside this triangle that I need? Keeping in mind, we must get a matching pair. Hello, everybody see what I'm showing you? So let's go. We have a side. Which angle does match with this side here? What is the opposite side to this angle? In between here. Everybody remember we had at a point in time found this angle in between here? Everybody remember that? Everybody see why it's useful now? So I just want to show you. Look at what we did in the beginning. We found the 8 without even knowing if we're going to need it or not. That is the point of evaluating your diagram. Because when you evaluate your diagram, you would then be able to remember, oh, man, I have this. So I could use this to do that. If you don't know what you have, there's no way you could determine what to do. And that's the point of this entire class today. Understanding how to get the things you need to answer the questions, because CXC will not give you everything. You're going to have to figure it out on your own. That's what you mentally have to be prepared for. Find the things that you need. Know what you're looking for. So I know inside here is 8 degrees. So isn't these two sides matching? And how the sine rule go? Side over sine angle over B over sine B angle. So let's go. I have A, because A would be what? 110. Agree or disagree? Over sine 8 degrees. Equal, I need something else. What is the side we want? This side, right? So let's call this B. Can I find, did they give me angle B? Let me see who thinking. They didn't give it to us, but can we find it? What do we use to find the angle B? And this is angle B here, eh? Remember, it's opposite. How do we find angle B? Let me see who thinking. Look at what is next to it. Okay, I love that. You could use angles in a triangle, or can't you use supplementary angles, which means 20 and this angle add up to 180. So you got two options. Excellent job, ladies. I really appreciate that everybody looking and they think are two different ways. Because either way gonna be correct, because 12 plus 8 is 20. 20 from 180 is 160. If you had used this 20 from 180 is 160. Everybody see what happened in there just now? So let's pause right here. So we have two approaches of finding the same angle that we need, whether it's supplementary angle or angles in a triangle. Okay, I can just keep it moving and hope that everybody, following and whatnot. So we know B sine 160. Now let me ask a question. Shouldn't you know what to do from here? Right? So I'm not doing the rest of that. So we're going to end right here for this question. So when you're done, you're going to find this angle here. Everybody with me? Thank you for always responding, Janelle. I appreciate you. Okay, good. Okay, good. No. So let's say we had an answer. Let's say this was 500 and something. That just create an abstract number. So let's say the answer we found here was 572. And then the right answer, just making up a number to represent the distance. Find the height of the lighthouse, TB. So what do you think we need to do now? Anybody realize this is trig ratio now? Anybody seen that? So let's call this X. So what angles we need to use now? Anybody realize what we're gonna have to do now? Here, am I using 70 or 78? Because look at the triangle. Very good. So is it tan? So this is 78. Is it tan, cosine, or cos? No, guys, look at it. How we gonna be sine? If this is the angle here, right? And we want X, how we gonna be sine when this is adjacent? Remember, it's gonna be cos because we got a hypotenuse. You see it? No worries, Lovey. Myrtle, you see it? Remember, 572 is what we just find. That's the hypotenuse. X is the adjacent, and we have the angle. So it's going to be cos 78 is equal to X over 572. And you solve for X. All right, guys. We did it. We finished our questions. So to wrap up class, I need you to tell me out of 10 how you feel about question 9. And be honest. How you feeling about question 9, especially in comparison to before. So I'm going to take this opportunity to highlight some important things that you need to know. Your number one priority, memorize your circle theorems and your angle laws. Without them, circle theorem gonna rip you up. You have to be able to look at the diagram, pick out all of the theorems that you see before you look at the question. If you cannot do that, you're not gonna be able to flow through the question easily. Keep it in mind also, how CXC patterns their questions is that they're gonna ask you to find one angle, and highly likely the other angle they're asking you to find gonna need that angle. And that's why we would call it direct questions and indirect questions. Direct questions is when we could look at it, pick a theorem, and we get the answer one time. Indirect questions are questions that you have to find something else first, something that you need to find the missing content. Everybody following me? Remember, you're trying to mentally prepare yourself as best as you can. Math is not just all about memorizing and studying. Of course, that's my job. Of course, I would always help as much as I can. So you're welcome. So that's some of the things when you're studying. Don't just try to read through papers. Also train yourself to find it on your own. So get a bunch of them by yourself and see if you could find all of the theorems. See how much you can answer by yourself. If you can't figure it out, go look for the answer and then say, oh, and then go back and see if you could find it again by yourself. When it comes now to bearings and trigonometry, separate in your mind. Right angle triangle only deals with trig ratios and Pythagoras theorem. Non-right angle triangles deal only with what? Cosine rule and sine rule. So when you see a right angle triangle, you should never write down cosine or sine rule. You should know that. And you shouldn't be confused because you know how to think. You know how to set out the information in your head. And you know the difference between the sine and the cosine rule. All right, don't make me cry. Everybody here sending comments in the chat like how you want to make me cry.
Miss V?
Yes.
One question. So back to the question we were just doing. If I were to use the angle at the 12-degree angle with the other one, wouldn't I use the sine rule for that instead as opposed to using the 78 degrees?
Wait, okay, I want to be specific. So let me go back so I could make sure I could answer correctly. So this is the one you're talking about?
Yes. If I
Okay.
used the 12 degrees, wouldn't I use the sine rule instead of using the 78 degrees?
When you say the 12 rule, you mean up here?
No, the 12 to the bottom.
Yeah.
Yes. If I were to use
Oh,
the
yes.
sine.
Okay. Then it would have been opposite, yes. Because X would have been opposite with yes. And I like how you bring that up.
Because that's why I had
Because,
to sine, because I was looking at the
okay,
12 down there.
I got you. And that's a perfect example. So what she's saying is that this is the triangle she used, to be honest. And to be honest, I think I prefer this one too over the other one, to be very honest with you. Everybody see what she's saying? So thank you very much for speaking up, because it may become even easier for somebody else. So because it's this is the X, we got the hypotenuse, which was the 5 something. This is the opposite over hypotenuse. So instead you would use sine. Okay? I actually prefer that one. And that was the purpose of us finding 12 and 20 to begin with. So excellent observation. All right. So guys, please make sure maths is not like the other subjects. The other subject, you study one thing, it's gonna come back over and over. Maths, I gonna teach you A plus B, but guess what CXC gonna do? CXC gonna hide B somewhere. They're gonna give you A, but they're gonna hide B. And guess what your job is to do? Find B so you could add it. So please do not think basic. Mentally prepare yourself for the challenge. They're gonna give you a lot of worded problems. Practice reading them and understanding the information. Okay? Everybody with me? I don't care how hard the exam is. What I should do when I see that exam is tell myself, yo, my students mentally prepared to work through that challenge. It's challenging, yeah, but that don't mean they can't handle it. So I'm telling you no, prepare for a challenge. All right. So tomorrow we have class at 6. What is our topic tomorrow? Vectors and matrices. I know a lot of you have told me that's your weakness. Please make it to class, because I'm going to take my time, and just like what I did today, I'm going to do it tomorrow so that I could feel good about us mashing up the second section of the exam. And letting you know, it is your job to mash up question 1, question 2, question 4. I won't give you a chance to question 3. Even question 5, these are the topics. Fractions. Nobody should come here telling me they don't know how to add, multiply, subtract, divide, no fractions. Not till today. If you know you're weak, go fix yourself. Okay? Also, last thing, please do the quizzes. I do not care if you get 0 on 30. The point is not for the marks. Those questions are CXC questions that are going to help you practice. The answers will be at the end. So you go back and you say, okay, I get this wrong. This is the answer. How do I get that answer? Everybody with me? This is the last question I ask you. Are you with me and understand the purpose of the quizzes? It's the difference between a fail and a 3, a 3 and a 2, a 2 and a 1. You're supposed to be looking for your weaknesses. I don't post them up tonight. I'm going to type up the 4 more on vectors, geometry, statistics, and something else. So look out for the 4 new quizzes. Those who have not done any, please go do them, please, before I start chopping up people with love, obviously, with nothing else. But I'll call you and abuse you if I have to. We have 4 weeks to go. Let us do it. I am going to turn gangster on you people, because at the end you're gonna call me and say, "But Miss V, thanks a lot for all the tough love and blah blah blah." So Elena, I know what time it is. Rough mode now. Get the work done. The harder you work, the less stress you're gonna feel in the exam. You're gonna feel so good that you push so hard. All right. So that's it for today, my peoples. Have a good night. See you tomorrow. Yes. You can ask me a question. Yes. All right. Yeah. But everybody else, you're good to go. You can leave. See you guys tomorrow. Bye.